Okay, you decided to come back for more. I am so excited. Section 1-2, line segments and distance. Now what we're going to do is we're going to divide this section up into two different lessons. But there's a pattern that's going to start emerging here in section 2 that the book will follow throughout. That is, first they'll let us practice these principles using just numbers, and then they're going to throw in the same principles using abstract terms. In other words, algebraic expressions. The process will be the same, and that's what we need to wrap our heads around. Okay, you need to read pages 14, 15, 16, 17, 18, 19, and the work begins on page 20. For the first part of this, I've made some notes, and you also need to make some notes. Pay particular attention to the highlighted words. Here are my notes that I've made on section number 1. It's not all-inclusive. Some things that help me remember what this section is talking about. If you need to pause this video and make a copy of my notes, go ahead. But this is what your notes should look like so that you will have them to use when you start doing the work. It can be right there beside your work. This section talks about line segments. A line segment is different from a line because it definitely has a starting point and it definitely has an ending point. It's a portion of a line. A line never starts anywhere and it never ends anywhere. It goes from infinity this way to infinity that way. The symbolism for a line is either line and then 2 capital letters for 2 points on the line, or symbolically the line symbol with those 2 capital letters. A segment can be represented by the word segment with the 2 capital letters, meaning it definitely starts here, definitely ends there. And symbolically, just a bar with no arrows and the 2 capital letters. You would read this as segment AB. This is read as line AB. This describes just a portion of this line, the distance from point A to point B, everything included between those 2 points, and the points. This section introduces what's called the segment addition postulate. The parts of a line segment added together equal the whole. And you might be going, well, duh. Trust me when I say this isn't as simple to some people as it is to the others. When you have a line segment AC, B is between point A and C. Doesn't mean it's in the middle. It's just between points A and C. That divides this line segment up into 2 smaller line segments. What is the distance from A to C? Well, you just add up the parts that make the whole thing. 5 plus 2 equals 7. Segment AC equals 7. Add the parts up, it equals the whole. However, the whole minus a part equals the other part. If I know that the entire thing is 7, and I only know that from A to B is 5, then I can calculate how far it is from B to C, since I know how much the whole thing is. 7 take away this part, the whole take away this part, equals this part. I've represented that right here. Here's a line segment going from X to Z, and Y is between X and Z. Now this part from Y to Z, this part is 11. In my information, I find out that the whole thing is 15. From X to Z is 15. So how far is it from X to Y? You take the whole, you subtract off the part that you know, and you're left with the part that you don't know. The whole thing is 15. Take away the 11. This part must equal 4. Now, one thing that I didn't write down in my notes that this section covers is congruent. Congruent is geometry's way of saying equal. Let's do X, Y, and Z. Here's a line segment. Segment X, Z. We also have segment XY and segment YZ. If there's a dash on both of these segments, that means that they have the same measure. We write that out like this. We talk about segment XY. It's a segment, so it gets a bar over the top. And segment YZ. Congruent is geometry's word for equal. It doesn't really mean equal. It means the measures are so close to being exactly the same that we're going to call them the same. And here's the symbol for congruent. It's an equal sign with a little squiggly line over the top. Segment XY is congruent to segment YZ. For our purposes, that will mean that they have the same measure. Now, how does that help us? If I know that segment XZ, the whole thing, equals 12. Segment XZ is made up of these two congruent pieces. Two congruent pieces. Two pieces that are the same. That means that segment XZ divided by 2 equals 6, which means that segment XY equals 6 and segment YZ also equals 6. These two bars, in the book they will be read, means they have the same measure. Absolute value. Absolute value means how far apart 2 points are on the number line. And it is always positive. It's a distance. And distance is always positive. You can't pull out a ruler and measure -5 inches. Impossible. Distance is always positive. Here's the symbolism. These bars mean absolute value. This expression is asking the question, what is the absolute value of 5? The absolute value of 5 is 5. Always positive. The absolute value of -5 is also positive 5. The number 5 is 5 units away from 0 on the number line. The absolute value of -5, well, -5 is also 5 units away from 0 on the number line. The calculator will do absolute value. If you go to math and then number, I just went over 1. It's ABS. Number 1 stands for absolute value. Push enter. Type in -99, enter. It tells you the answer is +99. I hope you can see that on the screen. Absolute value. And I think these are enough notes for us to get started with our work. Like I said, I'm going to divide this chapter up into 2 different assignments. I'm going to work some examples with you. I will do the odd numbers. Let's start with number 1. Find each measure. Assume that the figures are not drawn to scale. Right? CD means how far is it from point C to point D. So number 1, from C to D. Well, that's the whole thing. This is the segment addition postulate. CD equals 1.1 plus 2.7 equals 3.8 inches. It's done. And number 2 is the other way around. Here, this is how the book is going to tell you how much the whole thing measures from R to T. Measures 4 centimeters. This one part is 1.6 centimeters. So how much does this part need to be so that when you add them up, you get 4? I'm going to leave that for you to figure out. Number 3, find the value of X and segment BC, or the distance from B to C, if B is between C and D. To help me, I'm going to draw a little picture here. B is between C and D. So C is where I start, D is where I end, and B is somewhere in between. Okay, so I start at C, I end at D, and B is somewhere in between. Right. From C to B equals 2x. So 2x, I'm going to write that in there. From B to D is 4x. 4x. And BD equals 12. Well, they gave me a big clue right there. Equals 12. Well, the question is, how far is it, or what is the value of X? Well, they told me that BD equals 12 and BD equals 4X. So I just solve this and I'll know how much X is. 4X equals 12. All right. Get all the X's to the same side. It's done. Move everything else to the other side. That's done. Divide by the number in front of X. So divide by 4, divide by 4. That cancels out. X equals 12 divided by 4 is 3. There's my answer. Not too bad, huh? Number 5. Use the number line to find each measure. Number 5. From X to Y. X, Y equals. If you look, X is a negative number. Y is a positive number. Distance. How far from X to Y? I'm just simply going to count how many steps it takes for me to get from X to Y. 1, 2, 3, 4, 5, 6, 7, 8. The answer is 8. That's it. Distance is always positive. All right. Number 7 uses this picture over here. Graduating classes have buried time capsules on the campus of Eastside High School for over 20 years. Points on the diagram show the position of 3 time capsules. Find the distance between each pair of time capsules. We're going to skip these because that's the distance formula, and we're going to be working on that tomorrow. So let's drop down here to 11 through 16. Number 11. Find each measure. Assume the figures are not drawn to scale. Number 11 says JL. That means what's the distance from J to L? From J to L. Okay, so number 11. Okay. From J to L is the whole thing. So JL equals this part plus this part. So 0.75 plus 0.35 equals 1.1 centimeters. The parts added together equal the whole. 13. From S to V, from S to V. That is not the whole thing. That's a part. In order to find the measure of the part that's missing, I start with the whole. I subtract off the part that I do know. So, SV equals 4.1 minus 2.6. Equals, I believe that's 1.5, but let me check my work. 4.1 minus 2.6, 1.5. 1.5, and that's in inches. Number 15. I'm seeing a lot going on there in number 15. How far is it from F to G? From F to G. Well, here's the information that I'm given. The entire thing is 16.8. Each one of the parts, now there's more than two. There's 1, 2, 3, 4. And each part has a little red dash on it. That means each part is congruent to all the other parts. The whole thing is split into 4 equal parts. FG is one of those parts. So FG is going to equal 16.8 divided by 4 equals 4.2 centimeters. That's a 6 right there. 16.8. If it were only 2, or 3, I would have divided by 2 or 3. All right, that's where we're going to stop for today. Your assignment, this is section 1, 2. Your assignment is going to be 2, 4, 6, and then 12, 14, 16. 2, 4, 6, 12, 14, 16. Just 6 problems. Tomorrow we're going to come back and we're going to address the distance formula.